Okay, maybe we can get started, I guess. Cool. So welcome. This class is about like a generative AI, and this is ATLS and a computer science class listed courses. So yeah, my name is Ryo Suzuki. I'm a assistant prof in the ATLS Institute. And I also co-teach with the computer science too. So today's plan is about, I'm going to talk about an introduction and also course characteristics and objective and class structure and grading and evaluation. So this is the first maybe 30 to 40 minutes. And then after that, I'm going to also talk about the first lecture today about this like a large language model and also scaling modes for the AI. So yeah, so that is the plan. And now, first of all, let me introduce myself. So my name is Ryo Suzuki. So you could just kind of call me Ryo. And I'm an assistant professor in ATLS Institute and Computer Science. And previously, I was also a professor in University of Calgary in Canada. And even before that, I was a PhD student here in Computer Science, graduated 2020. And I also work with like some other tech companies such as Google, Microsoft, Adobe, and also did some kind of internship at Stanford, Berkeley, and so on and so forth. And my main research area in the human-computer interaction, focusing on how we can kind of integrate AI into augmented reality, like glasses, that kind of thing, and also like how can we make like a tangible interaction and robotics for more. So kind of focusing on blending like a digital and physical world as well. But especially nowadays, we are kind of focusing on like how AI, or especially generative AI, more. Is that opening? Oh, doors locked. Oh, sorry. Yeah, and so this is my website. So you could also kind of see like some of the products that you are interested in. So these are kind of the products that we have been working on, how we could integrate AR and AI for many different purposes. So this course is more focusing on like a generative AI. So I am more talking about like lecturing about the fundamentals of the generative AI and also advanced topics for more recent one. And for the course syllabus, I guess I've already uploaded on in Canvas, but maybe some of you. Oh, I realized the computer science CSCI computer science courses is not appropriately set up for the Canvas. I'm kind of asking them to fix it. So but mostly we use the syllabus on Notion. So the Canvas is just only for assignment upload and so on, that kind of thing. And this is a link. And you can see all of the information in here in this one. And so from the scheduling, I'm gonna also go through the schedule today. And for each week, for example, for week one, if you click this here, you can also see the slides, so the post material and slides. So this is what I'm using right now, and week one is about I am using the slides, and also some links or the differences. I think that maybe there may not be enough here, but please kind of try to split it. And then the resources as well for each week. And also some kind of cost evaluation and a policy, grading and evaluation, and so on and so forth. So just kind of please try to refer to this slide. So this syllabus. So here, again, as I said, you could also get this link from the Canvas. Yeah, the link is here, just in case. Okay. So about class, while this is ATLS courses, and I usually gonna teach more like a, how to say, like a project or like a tutorial oriented courses. So this one is more like a lecture based courses. So in a typical class, I kind of give you a lecture about more like a fundamental of the generative AI. And so, but also we do some kind of in-person discussion on exercises or a quick demo during the class as well. But most of the case, most of the kind of like a purposes of this class and classroom is more gonna try to understand the basics of the like how the like a AI works, that kind of thing. And also I'm gonna introduce the papers and how like some of the advanced system works more. Not deep in coding and not deep in theoretical math, but more kind of trying to, how to say, kind of trying to have an overall understanding of the different aspect of the generative AI. So the topics covered and during the reporting is like this. I can also go through each of them later. So today is I'm gonna just talk about overview and introduction, but starting from the language models and also the scale and laws for natural language processing research. And the next week is Martin Luther King Jr. Day, so we don't have any classes. And for the week 3, we cover GPT. GPT is maybe you know the ChatGPT, but GPT is like a chat, like a backend of the ChatGPT, and how the GPT works, and also most importantly, like a transformer architecture works as well. And so we do some kind of exercises about like how each of the component works. And for the assignment, we also do some like actual kind of Python-based assignment about like how it's trained. And week 4 is about RAG. Have you ever heard of RAG before? Oh, okay. Oh, cool. So RAG is a retrieval augmented generation. So which is kind of how the ChatGPT, how can we kind of enhance and augment like a ChatGPT, like LLM, to more factually collect data and information. So that is also kind of coming from 2023, 2022 papers. So we can also cover it and then how RAG works and also do some kind of quick exercises. The reasoning is also kind of important domain for LLM, especially after like a DeepSeek R1 became like a reasoning model, and most of the kind of recent models is also kind of focusing on reasoning, such as the deep research or like a ChatGPT 01, 2, 3, 4, also focusing on reasoning. And MCP, have you heard MCP before? MCP is a model context protocol. So this is a kind of like API for LLM, and then how we could try to do it. And week 5 is about kind of AI agent and LLM agents. So agents is kind of not only just kind of respond to back, but you could also more kind of assign the task, and then how LLM can actually kind of work on the task independently. So it's not like a more like a different paradigm of the generative AI and LLM, especially since last year. And we also cover like how you could kind of make like a AI agent and agentic architecture works. And then the week 6 is also more like a multimodal model by covering vision and then diffusion model. So the diffusion model is the like a kind of like the image generation, such as DALL-E or Sora, mostly a diffusion model. But also important aspect is like how language can be connected to the vision model, which is often called a multimodal language model. So this is the kind of the first half of the courses about foundation. So this is more gonna like a kind of what we have to learn in the era of AI. And so yeah, I can also cover like most of them. This is kind of like a textbook level or that. And for the midterm, we only have a midterm, by the way. So we don't have a final exam. So we have a midterm to kind of try to check the understanding of this kind of fundamental. And then the later section is more like an advanced topic. So it's more like a more recent one, but more like application, such as I'm gonna cover like how this is actually one of the important aspects, but the robotics or the physical AI, and week 9, like a 3D, AR, and a video. And week 11, I think week 10 is sprint, is about human-centered AI or generative user interaction, user interfaces. Week 12, I'm still kind of considering like what I should cover, but currently this for the AI for science. And then the last one is for the feature alignment and AGI, ASI, and risks. And we have a final presentation in actually I think week 15, I guess. Yeah. Any questions so far?
You reiterate the weightage for every component, assignments, midterm, and final.
Yeah, I'm gonna cover it too. And also there are information here in the syllabus, but I'm gonna cover it later. So before going into the detail, I can also quickly touch upon the grading and evaluation. So it's a kind of around this 4, so the final product and midterm exam and assignments and attendance. So let me start from the midterm exam and the final. So midterm exam is more gonna, I just wanna check, I usually don't do the midterm exam, but this one is such a basic one. So I wanna check your understanding about especially the fundamental of the generative AI. So from the week 1 to week 6, because that is very basics about the understanding of AI. And we're just gonna use the entire week 7. So it may or may not take 2.5 hours, or maybe less than 2 hours, obviously. But you could just kind of sit down and spend a bunch of time. And this one is a closed book, so there's no differences or AI tool. Although we can also do that on campus. So just kind of bring your laptop and do it here. And so the format, I say probably like a multi-choice questions, so a bunch of multi-choice questions, I say. So because it's a kind of Canvas conference. And yeah, the exam will be conducted in the Canvas, so using your own laptop and tablets. Yeah. Yeah. And only midterm exam AI tools are not prohibited. So I gotta kind of look around, and then if you're kind of using it, maybe there should be the violation. But that is kind of midterm exam. Any questions about midterm? So there is that's a 30% of it. Yeah. Any questions about it so far? That's probably kind of clear enough. And then I'm planning to provide 2 assignments. So I think I kind of try to make sure the assignments as less time consuming as possible. But the goal of the assignment, the reason why I'm kind of doing an assignment is during the lecture, I mostly kind of talk about how to say the concept or knowledge about generative AI. And that I wanted to also kind of try to dive into more like an actual kind of, how to say, actual process, like a coding process or like an experiment process of the generative AI to So that is the goal of the assignment. So this is kind of using a Python, but I don't really expect, maybe half of them are computer science students, but especially for our students or our course, I don't really expect that kind of advanced skill for the Python, I would say. That is one kind of very, I would say, the goal of this kind of assignment is not really trying to evaluate coding skills, but it's more just using the code and then kind of trying to experiment and kind of trying to kind of understand what's like a GPT is working on, or like how the LLM agents works, and how you could kind of try to use it or integrate it into your system. And also evaluating coding skills is almost doesn't make sense anymore in the AI era because everybody can actually code. So I'm more focusing on kind of trying to let you understand this kind of concept by kind of learning by doing it. Yeah, so that is a goal. So the goal is more like experimental and experimentation and learning by doing it. So that is that is the goal. So I'm kind of trying to juggling around different type of assignments, but assignment 1 should be related about week 3. So the second part of the class, which is about GPT. So in the lecture, I'm gonna cover how the GPT works in a mathematical or architecture level, but I also want you to actually kind of try it out to a training process as well. So there's a kind of a nice, and I also don't have a TA, so I'm kind of using the Android as the TA, and she had a great resources for NanoGPT, and then I gotta let you to kind of try to actually run it and learn it, and also kind of using different data sets to see what happens. So I basically have 2 weeks for the duration, but it should be done very quickly, I assume. And so that is kind of I want you to try to understand how language model works and tokenization, embedding, transformer, GPT, and scaling works. So that is a goal of the assignments for the 10%. And assignment 2 is about trying to understand the agentic architecture model too. So how agent can actually kind of try to understand the memory and retrieve the memory, and how it can be used for the RAG, retrieval augment generation. And then one of the application, maybe assuming that you have you're kind of making a lifelong AI, and then kind of try to using this model to make one based on your history of your life, or maybe a history of your day, to make some kind of AI assistant or AI agent based on to try to answer based on context. So that is the kind of goal. So these are kind of the assignment. I'm gonna probably upload the actual assignment maybe in the next week. So maybe you could see before deciding the class to whether it actually fits or not. But I assume it's relatively easy. The goal is more than trying to let you understand. And yeah, I don't think it probably doesn't take that much time, but if you kind of submit late, it's kind of 20% deduction. So that is pretty much common. And for attendance, I just kind of check the attendance during the class or at the end of the class. So I do have list of the students here. So I just manually check it. That is the kind of easiest way to do it. So I'm gonna do it later. But that's that. But again, the goal of the attendance is first of all, I want you to kind of try to understand the generative AI, and also we do some kind of exercises, the group discussion or the peer discussion within the group to broaden and deepen your understanding. So that's why I just kind of check the attendance as well. And yeah, so just kind of try to be proactive, or at least kind of focus on during the class. So that is my hope. That is my hope. And if you have any kind of reasonable reason for the absence, just let me know before the class, and we could obviously kind of accommodate it. But maybe probably after 2 times, and after 3, it's more kind of negotiable. But at least for up to 2 times, you could kind of just kind of let me know, and I could kind of accommodate as much as possible for any reasonable reason. Any question for the midterm attendance and assignments so far? It's good. Okay. So the last one is about final project, and then since this is the kind of first time I gonna give you the lectures, I'm kind of trying to experiment it. But the final project is you could kind of work on any topic. So there's no, how to say it, a constraint in terms of topic. But I am kind of trying to provide like 2 tracks. Oh, like first of all, at the end of the class, the week 15, we have a project presentation day. And I realized that we have a lot of student enrollment. So I'm not sure how we can handle it, but maybe given that 5 to 10 minutes, like a very short presentation. But also there's you're gonna submit like a writings and a video on a slide. So like a presentation and a video, and also some sort of writing is the final project. And you can work on as a solo or the group of, actually given this number, maybe, yeah, I'm not sure, group up to 4 might be also okay. But you could also kind of form the group up to 3 or 4. And then you could just submit it as a group project. Yeah. So yeah, so that is the kind of the like a final product. And I also gonna talk about like what kind. Oh, in terms of what kind of products, there's no constraint. So any kind of topic is fine. But there are 2 tracks. So the first one, I think especially for the undergrad student, is for like a project or startup tracks. So that is the kind of first track. And the second track is more like an academia or the research, or someone who is more interested in kind of like a paper is the kind of academia or research track too. So let me kind of explain like each track. So the first track is about kind of project or like a so-called startup track. So that is more kind of focusing on like a deployable or like a working system by using AI or using a generative AI. So there are kind of tons of the AI startup out there, or any kind of startup that uses AI, or any kind of the product that uses AI out there. So the goal is kind of trying to develop that one by using AI. So the group should build the product that solves some kind of real world problem. So using AI. So any kind of problem or any kind of target user is fine. And the topic can be anything as long as AI is used. So I leave it there. I leave it to your creativity. And also, this is a kind of idea of like a startup pitch. And actually, I'm planning to invite one of the past PC here in ATLS to attend your class. And I kind of try to, if the promising is kind of, maybe he could kind of connect with the actual VC or the incubator later. But idea is kind of trying to kind of develop some project that can be usable or actually kind of used by the user. And then maybe that would be kind of very meaningful. So that is that's the kind of the goal. So, but it doesn't really have to be the company or like a startup. But for example, like a automated, like a you know, if you want to make like a YouTuber by using AI, and that is also fine. For example, and then you could kind of make actually kind of post it on the YouTube, and how many people actually going to watch it. This is also kind of one of the great products too. But I just want to make sure that like you're gonna actually kind of align to like a real world problem or the real world kind of context. Maybe it can be your problem, or it can be your parents' problem, or it can be, I don't know, someone in a restaurant or like a gas station or whatever. But I just want you to kind of trying to look at the world through the lens of the AI to solve the problem. and then actually gonna make the system. So that is the goal. And instead of kind of concept only product like a concept business, I just wanted to make some actual system because that is a kind of maybe nowadays you could like a bytecode almost anything. So making the system part is not hard, but actually kind of trying to identify the problem and kind of try to solve the problem is actually important. And then also actually gonna ask the target user or let the user use to get some feedback. That is the kind of the project or the startup track. So it's like a typical product, I would say. But one important aspect is by asking the actual user to receive some feedback. So that's the kind of product track. And for the product track, we basically gonna look at the quality of the demo and the system, and also evidence of some kind of real-world problem solving, such as user feedback, or track record, or even like make money, and understanding and a comparison with some kind of existing competitors or alternative. That is a kind of the that's the kind of the rough description about the product. Any question, by the way? I think this is the kind of the farm experience. Yeah.
Can you give examples of what maybe some students have done in the past?
Oh, so as I said, like I'm kind of giving a lecture today for the first time, so I don't have any kind of past example. So you're gonna be the example for the next year, I guess. I could also show you some of the. I'm kind of teaching like how to hack almost anything kind of mixed reality courses last year or two. I could also kind of show you some of the interesting products as well. Maybe in the next week-ish as well. Yeah. Yeah.
You were saying this is going to be done all year, or what portion of the class's final project plans?
Oh, so even if you have like, so I mean, like anything that can be done during the class, during a semester. So again, like you could kind of show you, oh, this is the kind of, how to say, like a direction that I want to go. And then during the class, oh, I made some kind of minimal viable product, which is kind of pretty common. And then I kind of test it out, and here's kind of what I learned. That is also fun too. So as long as something working, and something that people or you could actually use it, is the kind of goal. I don't really expect very, how to say, higher quality of finished product, honestly. Yep.
So we need to finish this project and get people to use it. What we do to have users.
Yeah. So again, like even like a couple of people is fine. Yeah. But again, like also sometimes that is the, how to say, like once you identify the problem, then maybe you could just kind of create some kind of even like a hard-coded version of it too. So I think it's more like a verification. Actually, testing is more important than the sophistication of the system too. Yeah. Yep.
I guess a follow-up question,
Yep.
because the rubric you currently have that for the final project indicates like getting the best score also means that you should be making money off this product.
Okay, so I can also follow it. So the baseline is probably A-, by the way, here in this case. So baseline is like a 90%. Is the once you kind of design based on the target user, and then also actually kind of the system working. And then if you have some kind of multiple users, for example, 2 or 3 users actually gonna use it, or if you kind of run this, run the experiment by doing it. And so that is the kind of base score, 90%. I think it's probably not too bad, right? And if you actually get money even from the single user, I could give a 100% score, probably. That is actually how it's fun. But so it's not really required. And then, but if you're actually gonna get some money, or you have actually gonna deploy to attract some substantial user, like 20, 30, or even like 50 users, or any kind of the impressive real world implication, I think this is more like a level of you could actually pitch to the VC and get money and start up. So this is the kind of level that you could do. But I don't really expect that much because this is the A plus. For the A level, if you actually have a system and like get some target user for handful number of the people, like 10 people, and that is great. Yeah, that's awesome. And then if you're just gonna like a working prototype, it's probably gonna R&B plus. And if the system is not even like a working, it's like just a concept level, it's more like this one. So yeah, I mean like the how to say target is high, but I assume the expectation is not that high, so don't worry much about it. And I kind of assume making a system is easier, much easier nowadays. So actually gonna using it like a testing and let the people use it is more important. So that's why I wanna do that too. Yeah. Yep.
How long do you have to like get 50 to 100 users from like when you finish it to when it's great?
Again, that's a good question. I don't know. But if you have already, by the way, if you have already been working on some project, you could also use it too as well. And so again, like, I don't really expect any. I don't expect this one, this level actually. But even without it, probably yeah, maybe you could kind of get like 95% score, right? Yeah. Any other questions? Maybe I can also kind of change the expectation a little bit too. But the idea of the startup track is you make a system and then let the user use it. And that is the goal. Yeah. Okay. Yeah. So the second track is about kind of academia or research track, especially if you are interested in kind of graduate school, or if you are already kind of graduate student. So the this part is more about kind of trying to read a paper and trying to make some kind of novel outcomes on top of the paper too. This is kind of what most of the graduate student does, I would say. So again, like a topic can be anything, and then the group should aim to write an academic paper in any domains, from the AI, HCI, graphics, robotics, or any domain can be found. And then the you just kind of student follow like a publication format, so it's more kind of writing is more important. So to take two kind of format of the paper, and then yeah, and then they kind of submit it by the end of the semester. That's all. That's it. And again, if you're working on your own like existing research or the project already, you could also use that too. The idea is like if you can kind of submit it, if you can kind of write a paper or write some kind of research by the end of the semester, that is the goal. And the topic can be, for example, you could also like make a system, or you could also like do some kind of benchmark for the system. You could also make like a data set, or you could also kind of do some evaluation and user study type of research as well. But again, like a topic or the direction can be anything, especially if you're kind of grad student and especially interested in kind of AI or any kind of research. That is you could kind of use this opportunity to develop your own ideas too. So grading criteria is also like it's more like a novelty and originality of the ideas, and a significance of contribution, and understanding comparison with the existing research. This is pretty much the same as the how review works in academia. So yeah, and then for the writing, just kind of try to write like a archive like a paper. Yeah. So yeah, so the rough grading criteria is again like A plus level is more like if we think, oh, this is actually pretty having a potential to you could actually submit it to one of the venue. That is the kind of level of the like A plus. And for the A minus, like a baseline is that like you actually gonna write a paper and it looks like a paper, like there is an intro, related work, like a method, and like a experiment and a discussion that can be somehow kind of publishable in the archive, for example, is the level of the baseline. So you could actually one of your colleagues, like a PhD students, or to review your paper, and then just gonna give me the review, and I also kind of consider it as one of the reviewer. So I can also review it, and also I'm gonna ask some colleagues to review, and actually, so it's one kind of reviewing process too. So that is the like a Python like A and A process as well. More like this level is like it seems like a very basic structure, but it's not. It's just only kind of replicating like existing work or that kind of thing. So these are more than, or it doesn't even seem like a research or academic paper. That is kind of going to be. Does that make sense? Yeah. So historically, in my past class, in the average is about between A to A minus. So I kind of expect most of the students could probably get at least an A minus, and I can also change the expectation based on it too. So I'm not really kind of trying to give you a bad grade, to be honest. But I just want you to kind of trying to, how to say, make something meaningful by the end of the class. That can be lead to one of the career. One of the career could be more like a project or a startup or any industry area or kind of research area. So I just want you to use it as an opportunity to, how to say, kind of grow your career. So that's why like, I don't have any specific topics or like a constraint. But at the same time, like I also want you to kind of try to, how to say, work throughout the semester to whatever you're interested in or you're excited about. That's kind of that's kind of the grading and evaluation. Any questions so far? It's good. Yep.
About how long would the paper be, you think? About how long would the paper be?
Oh, you mean for the second try?
Yes.
So there's a second, like a two column paper. It's a kind of common format. I kind of expect like 6 to 7 pages. With or without research. So it looks like a paper, right? Yeah. So that, yeah. Any other question? Cool. Yeah, so this is kind of the grading criteria. And I'd say if you just gonna keep appending, I just gotta check the attendance. So like if you just gonna keep appending, assignment should be relatively maybe easy, I'd say. So if you're just gonna work on a midterm exam and also like a final product throughout the semester, yeah, that's I hope maybe the average could be about, yeah, A minus is so more than A minus is the kind of that I'm kind of trying to aim for. But I don't want the class too harsh, but I also want you to work on, especially for the final product, seriously. That is a hope, and that can be the kind of example for the next year too. Yeah. So I hope, and actually, if someone can actually kind of publish the paper out of the class, or someone can actually kind of start a startup, that'd be super cool. Yeah. It kind of always happen in the Stanford, by the way. So that is kind of cool. Okay, so then for the AI tool policy, in a class, you could use ChatGPT or any tool, AI tool for whatever purposes, except for midterm exam. So, but just kind of please acknowledge, especially for assignment. Yeah, but for the assignment, there should be no exact answer because of probability. So, if there's kind of exact duplication, maybe that's gonna be more gonna not a AI tool, but it's probably gonna copy and paste it. So I think that I could kind of easily identify. So just I recommend you to just kind of work on this. Okay. And then I gonna also kind of briefly talk about what I can cover over the semester too. So the first week, today is I gonna talk about like what the language model is, anagram, and like a scaling mode. So these are kind of the keywords that I listed. I'm probably not gonna cover all of them, but yeah, especially kind of word feedback or stuff gonna be probably the next week. But it's more gonna try to understand the language models. Second week, no class. And for the third week is about GPT transformers and pre-training architecture and how the self-attention works and how GPT was made, that kind of thing. And fourth week is about retrieval augmented generation and tool use, chain of thought, and reasoning, and reinforcement learning with human feedback, that kind of thing, like how is it actually going to make the LLM more fact-oriented and efficient. And fifth week is about AI agents or LLM agents and what's the kind of benchmark in constitutional AI and long chain as well. And sixth week is like a vision and a diffusion model, such as kind of convolutional neural networks, multimodal LLMs, and also like a DALL-E clip, text image model, text video model, like that. Seventh week is about kind of midterm exam. And for the later of the session is about kind of robotics, physical AI, vision, language action model, word model, that kind of things. Ninth week is kind of Gen AI for the 3D, AR, and video, such as kind of always on AI or generative AI for AR, generative video, AR, like a text to 3D, spatial understanding, for the spring break. And the 11th week is the Gen AI for HCI, human computer interaction, such as human-centered AI, generative UI, direct manipulation versus AI agent. 12th week, maybe for the AI scientists, like an AlphaFold or lab automation. And then the last week of the lecture is the alignment, like a future and risks, such as singularity, SI, and that kind of things. So there's no class because I have to attend the conference. And then the final week is like a final product presentation. Yeah. So that's all. Any questions so far? Good. Okay. Cool. Then maybe I'm gonna just kind of check the attendance for quick. I also realized there are a bunch of the wait lists as well. Actually gonna ask them if we can kind of change the classroom to expand it, but they said there's no classroom anymore. So one of the possibility, only one possibility is just gonna create like a remote session to do it. I'm not sure if you want to do that too, but that is kind of a possibility to. When is the kind of wait list registration deadline, by the way? Is that like 2 weeks from now? 2 weeks from now? For those kind of who are wait list, like do you attend even with remote one? If so, maybe one. But to be honest, like maybe I kind of assume like some student kind of drop out from today. So maybe let's see like how many kind of left. But maybe the next week we gonna figure out if there's kind of still a reasonable amount of the wait list. Maybe I could open the remote one too. Although seems like a classroom could somehow accommodate. So I can just kind of open the remote one and you could take it. I actually don't know the logistic, by the way, but you could still kind of come to the class too. That might work. Anyway, let me quickly take another. Nathan.
Right?
Oh.
There's me.
Okay. Wait. Josephine.
Sorry, I thought you said Latham, not Nathan.
Sorry. Oh, yeah, Nathan.
I'm George.
Okay. Oh wait, Nathan Alice. Josephine Armstrong. Zach. Zach.
Oh,
Okay. Graham.
right.
Okay. Wait, Zachary. Right here. Okay. Sanj Gore. Okay, maybe probably we're gonna have like enough space, but Mikar. Okay. Melody. Eddie. L. Lexa.
Here.
Grain.
Here.
Sorry, Granny. Nichols.
Here.
Olivia. Cole. Aiden. Jessica.
Here.
Kendall. JC.
Here.
Hara. Ritan. Mandar Mahesh. Thank you. Mithresh. Sorry, Mithresh. Sagar Mahesh. Anna Lawson. Lily. Shabita. Vanasti. Late.
He just stepped out, but he's here.
Okay. Shahed. Arjun. Abdel.
You.
Adil. Noah. David.
Here.
Lance.
Here.
Samir.
Here.
George.
Here.
And Marson.
Here.
Nasir.
Here.
Kai. Rowan.
Here.
Daniel.
Here.
Shri. Ben.
Here.
Okay. Adam. Joel. Ishini.
Here.
Dima.
Here.
Stainslow. Heyon. Manotonia. Narmi. Project. Jay. Western. Rina. Anirudh. Karen. Kara.
Here.
Jihan. Cool. Let's take a break for, maybe we can kind of start at 20. Yeah. So maybe you can kind of take a break until 20.
Yeah, connected to one. But on my laptop, I'm not able to connect. Wait a minute. Basically, for my source, it was trying to wait to it. Then I was able to download the certificate, right? And then when the certificate was there, I
Oh, okay. Wait, so just.
I haven't installed any application.
Yeah, so
It's, can you even?
Without Wi-Fi.
no, I can't, because
So.
I was from asking like, if I leave.
Can I get it?
Oh, today?
Oh, yeah, today.
Oh, yeah, sure. Yes, I already checked it, yeah.
Okay, so.
So maybe it's, yeah, I will upload it. And, yeah, I will. But I guess maybe you could still attend the group. I think. Right. So I have the, like, there is some kind of statistics, so I gotta ask them. Ask our lesson from the house, you don't know.
That's fine.
Maybe there, but anyway, yeah, I gotta make it more.
Yeah.
It is.
Some favorite section where like, just doing paper class and.
Okay, so these are kind of groups, just the same.
Yes, like doing paper class and then just do. On civil, do something lecture.
Okay, sure. Oh, yeah, that's fine then. Yeah. Okay.
If you would like.
And the last day to like drop an out of class.
Yeah, so probably gonna open the demo session.
Okay.
Maybe.
Maybe we can also like come in person if there's seats, because we're 1 and 2 on the wait list, so.
Oh, yeah, so I think so I never done the demo session before, the Josh recommended open the demo session where people can just take it.
Okay.
Yeah, but still, I guess maybe.
But I'll still come.
Oh, yeah.
Yeah, okay.
Yeah, I can, so there's no difference here,
Okay.
to be honest. Yeah,
Okay.
in my understanding, yeah, I'll figure out that.
Okay, thank you. I think, it's like we've had like teachers in the past, they just will say an announcement. If like they can plan on job waiting, so I don't know if you'd be willing to like. Do that,
Yeah,
just cause it's.
I could do it, but there is kind of 20 wait lists, so.
Oh, cause is there 3 different classes in this one? Cause arts on Canvas shows we're 1 and 2,
Oh, really?
like spots on it, but it only says our class has 10 people.
So
So is there like multiple?
I thought you are going to increase it because I
Yeah.
am seeing more than.
So I asked them to increase it, but they said no, so one of the only.
That's it.
What's that? So I could kind of, so maybe we could somehow balance it.
Yeah.
But
Remote's fine, yeah,
Yeah.
too, yeah.
Maybe something, like how many students are currently there? Because I see 4.
yeah, I mean, like there are like 40 enrollment and 20 enrollment. Although, yeah,
I'm currently as well.
no, I mean, it's not like you're kind of taking.
I actually wanted to talk about yourself. I currently working on the business. Is the vision and how the programs to say. Yes, I'm fine. Before to yes, we have this executive destination is actually currently the is all about if you increase the reasoning, its models are better. But actually, it depends on how you are training the model. What the instruct model
Use this part
So I wanted to actually check regarding
I use some.
abundance condition that project. I'm not sure I have checked it.
Yeah, I mean, like, you could do it.
But because the criteria is like, because I'm working on that project as well and it requires something else. Like, I have my independent study as well. So I was worried.
Yeah, I mean, like, it's up to you, but I don't really, you don't, you could, you can just kind of do it. You can just kind of use some build on top of it. Problem.
So do you want a journal paper or system paper that was fine?
Position paper.
Position papers for ICM is 8.
Okay. Yeah.
But it's more about like what is not there, so specific, what you're actually trying to position about and make people think of something that people haven't.
I mean, as long as you submit it to any of those, like yeah, just gonna use.
Yeah, I don't know.
Use the time. Yeah. Yeah. I mean, just use the time. So I just don't want the students to work something irrelevant to your business. Yeah. So that's right. That's the whole. So.
But you mentioned that reviewer that.
No, I mean, I gotta be like.
Yeah, but my paper I'll be submitting now, so I'm not sure.
Oh no, you just gotta ask one of your.
Okay, no, I don't know whether I will be able to see because I be submitting the thing, so I say I
Yeah, no, the review is that kind of way.
Is it fine to reuse the paper which will be submitted by?
Yeah, that's fine. Oh, okay. I haven't taken. So like a what? Yeah,
That's also true.
Oh, okay. So you mean like a? Do you wanna? Separate room or?
Yeah. So.
Right. Yeah, that's great. I'm not sure whether it's like a product or something.
Yeah.
Yeah, I think that's.
We are able to like.
Oh, yeah, that's probably just so awesome.
Depends on like reading of something. Or it's based on the class time.
I can think about it. That again, like it's so multi choice.
Just based on the class time, right?
No, always do it.
All right. Maybe I could get started. You. Okay, one and a half. Yeah. Let's see like how I can fit it. But anyway, so today's topic is about language models and also scaling more. But first of all, I think you heard a lot about LLM, like what does it stand for? Yeah. What is an LLM? Yeah.
Large language.
Yeah, so this is a large language model. And so that is basically gonna like a language model, which is large. So that is the kind of large language model. And I think a large is fine. So this seems like a large. And then you the question is like, what do you mean by large? Like what large, and how large, and also why large? But large kind of makes sense. But another question is about, okay, like what is the language model? So what are the language models? That's can you do you know what language model are? Just a guess or anybody? The answer yes.
Model that use words methods input.
Mhm. Okay, that's half of the answer. Anyway, yep.
Those are machine learning models that work with natural language.
Okay, kind of close. Anyone else? Yes.
A model that would predict the next word in the sequence.
That's good. So the model is often called it's kind of like a model of the system, right? So there are kind of a bunch of the system. For instance, economic system is one of them, or like a mechanical system, like an elevator is one of the system, right? And even like a music instrument, like a piano is also system. And then the model is kind of trying to simplify the system, kind of trying to understand it. And then the system is usually something input and something output, right? For example, like a piano, like you just kind of press it and then like a sound comes in, right? And then model is kind of trying to understand like how the piano is made. And here, in this case, the language model is the model is like an input of the language model is actually like a language or the word, or even like a characters. Okay. What is the output of the language model in this case? Anyone?
The same.
The language? Yeah. So the language input and language output is one of them. But there's actually one of the most important aspects of the language model is as he said, like a language model is a model to learn like statistical patterns of a language and then to predict the next word. The more important one is it's actually kind of language input and the probability output. So that is the kind of model of the language. And what I can kind of explain like what it means by probability of a language. So that's, like a language is just a kind of set of the words, right? And the words is also set of the character. But in this case, that's only focusing on the word, right? And you just kind of make the English sentences by just kind of aligning like a words. But some sentences make sense, or some sentences don't make sense. And what it means by make sense, or what it means by doesn't make sense, is in a mathematical, in a machine learning model, it says it's like a probability of the sentence is full. So in this case, the language model represents the probability distribution over a sequence of the words. So that is the kind of important aspect. And the words often called like a token, by the way, which is going to be covered next week. So in other words, it's fine the numerical score have natural sentences. So that's the kind of language model. So for example, so I went to the school today. So this is a very natural, right? But why natural? And then school today, I today went to. So this is kind of not natural. But why? What I mean by natural? What is the often called the probability of this sentence exists in a word is the higher. For example, this 38% or something. And the probability of this sentence exists in a word is I don't know, like a 0.001. This is the kind of just random number, by the way. It's kind of like an essence of what it means by a language model. So the language model is actually going to converse the language or the sequence of the word into the probability. And then why it matters. So because sometimes it could also not only grammatically correct words or the grammatically correct sentences, but it could also somehow understand the knowledge as well, right? So for instance, in this case, the capital of Japan is Tokyo and the capital of Japan is Paris are both grammatically correct, right? But if you look at, for example, if you look at a Wikipedia or any kind of blog post or internet, maybe you could see these sentences, but you probably can't see this sentence. So meaning that the both sentences are grammatically correct, but if you kind of look at and compare the probability of this sentence with this, then actually you understand the Tokyo is the capital of Japan is, right? So that is kind of how the language model can actually understand not only about kind of grammatically correct sentences, but also knowledge.
It references these to its training data to determine the probability.
Oh, it's I can also cover it later, but this part is more gonna not given the training data, this is the system. So let me explain. So in AI, there are kind of two types of the session. One is the training. So training is like OpenAI people or Google, it's making actual ChatGPT. And then OpenAI actually gonna make like a large language model. And then now what you do every day is just you provide a sentence to the model, and then it just provide sentences, right? But to generate it, what it actually do is compute the probability, and then you can actually get that convert the probability of numerical data to the word. And then what it does here is you have like a language model, and then this is the sentence. The capital of Japan is Tokyo, and then the output is 0.02, and then the different input to the capital of Paris, and then you can get the 0.00. Okay. So that is more like it's not training, but it's more like an inference fund. So this is the just point. Yep.
So the center of your model that you're drawing on the board over there would be the probability that that this sequence should occur in the language that's in that model.
Yeah. So that's a good question.
So if let's say that I wanted to have the thing respond like a doctor, would I would I make it do that by changing that model that the probability is derived from?
No, that's a good question. I gotta also that is a good question that I want to cover later.
Oh.
But one possibility is that it just memorize everything. So that it's just trying to check the sentences, and then it looks like the capital of Japan is inside of the large data set. Well, that's one of them. But large language model right now is not that kind of thing. But the language model in general is just language in and probability out. And then how it works is different based on the model, the different of the training or different architecture, which can also cover later. So in a mathematical model, in math, if you write it down more formally, that is the just like that. So x1, x2, xl. So these are words or something like tokens of the characters. Yeah, character. And then you can get a probability of this sequence is for example, in this case, the capital of the town is Tokyo, and then you can get a probability of some 2% of it. So that's the what the language model is in general. And then meaning that if in the probability theory, sentence probability can be also decomposed into the one sentence and then the words next to the sentence. So, for example, right now, this is a sentence right now. But if you wanna, for example, if you do have the sentence here, right? And then what you want to do is basically not only like a Tokyo or the Paris, but you have like a million, not a million, maybe 1,000 of the words, and then you want to get like a which word is gonna be most likely. Right? So in this case, this is often called like conditional probability, meaning that like given you have this sentence, and the next word is gonna Tokyo is 0.02 or something. And the next word is the Paris is the something like that. But this cannot be done with the Tokyo and Paris. You could just kind of put the next word here and get the probability right. So if you have like 1,000 of the words, you can actually kind of get the actual results of the probability. That is kind of called the conditional probabilities. And then we can kind of generate. So by using this kind of the concept, we could basically kind of generate the text like a step by step. So idea of the conditional probability is something like that. So you have the words, the dress color was, and then here's the kind of question, right? So you wanna guess, and then I mean there should be like 1,000 or tens of the thousands of the words in the English, maybe in the English dictionary, right? And then you just gonna put each word here to the model. So this is the model, this is the probability, right? So you have maybe like tens of thousands of the words in the English dictionary, and you just gotta put each of them, and then you can get the probability distribution of the given this sentence. What is the next word, right? And if you do have the probability, what happens is meaning that like if you can pick the higher probability, it's gonna be more likely, meaning that more natural or maybe factually correct answer, right? So so for example, in this case, the dress color was, and then most of the kind of higher probability words is gonna be about colors, right? Because it talk about color. It's not gonna say like cat or something, because it's just gonna have the probability words. And this is also like if you look at like a probability, and you could also see the kind of like a grammatically correct words is gonna be also derived from by looking at the probability distribution. For example, the white was at is not grammatically correct, but the model is not really checking the grammar itself, but it actually can choose the most likely words, next word, which is the most likely next word is gonna be like grammatically correct if you actually can learn a lot of the text. So yes, so the language model can be written as like a product of this kind of conditional probability. So if you wanna estimate this sentence of the probability, then you can just kind of calculate the probability one by one. Right? So the first one is how much the probability was z at the very beginning, and the capital given the z of given the capital, and the Japan given the capital of and so on and so forth. And then you could just kind of get the total probability of this specific sentence in this way. So that is a kind of the what the language model is. So when you are asked like what's the language model, then you can answer it. The language model basically just kind of given the language or given the sentence or given the sequence of the word, it generate the probability, or even like generate the probability distribution. And then so that like you just kind of pick the highest probability of the word, then you could just kind of make the sentences, right? That is a kind of language model. And then important question is, given we have some medical system model here, and then you just kind of put the sentence of the word, and we can kind of get the next word prediction or the next probability of its prediction, right? But we are not really, we haven't talked about like how we can get this model, right? So this is a kind of training, a learning phase about how we can get this magical model. And here is a kind of history of language model. By the way, language model has been like done the research over 30, maybe more than 40 years back. So it's not like a recent one. I mean, like there is a kind of research domain called natural language processing, NLP, which exists more than like 50, 60 years ago too. And even before machine learning model, the people think about the, how to say, people kind of determine the next word by using rule-based approach. So for example, like if you have the capital, then the next word rule is gonna be odd, and then and so on and so forth. But immediately people understand, oh, this rule-based approach is not possible. It's so complicated. That was like 90s, 80s, I guess. So there is a kind of one of the peak of the AI in 1980s in the rule-based approach, and then it failed. So there is kind of a first winter of the AI in the 1980s. And then in the 1990s, the rule-based approach doesn't work. So maybe we can kind of convert language into the probability. So it's more like a mathematical problem. So that's the machine learning model. So this is the kind of machine learning model is basically everything is kind of converted into the math model and a probability distribution, and try to see like what happened. And so that is the kind of 1990s. And then 2012 or maybe like early 2000, people start thinking about, oh, there's kind of deep learning model. Mostly cover next week. And then in 2017, there is kind of transformer model happened in 2017. And then this is going to ChatGPT right now. So language model is not only about like a transformer or the deep learning model, but it can be anything, even from a rule-based one or the machine learning one. And I can also talk about the pre deep learning era of the language, and then kind of try to understand like how it can be actually kind of learned. So as a practice, so next week, actually 2 weeks from now, I'm gonna actually cover a large language model. But as a practice, today we are more focusing on a very small language model. So very small language model means that we could actually train the model based on 6 sentences. So this is a training data set. Okay. So we have now 6 sentences in the training data set. So knowledge, so all of the knowledge that model has is these sentences. Okay. First one, I live in New York with my parents. I'm studying at the University of New York. I like studying computer science. I like to eat apple and banana. I have a computer called Apple. My parents live in Colorado. That kind of thing. And then, like, given this one with a very small language model, I'm gonna trying to demonstrate how the language model can be actually be trained. So, as I said, language model is basically the probability of each word, right? So, meaning that the language model can actually kind of try to identify. So, given, for example, I pick I as the first language, Okay. Then if so, this is more like a manual, like a human-based language model, by the way. Given this example sentences, if you have an I, what is the probability of is, okay, if you look at count, okay, given like given I, right? So next word is 1 out of 5, right? So which means that probability is how much? Yeah, so 1 out of 5, so it's 20%, right? And a leap is the same way, like okay, if you look at leap is only 1, so 1 out of 5, 20%. Like there are 2, so 2 out of 4 is a 40%, and half is 20%. So that is a probability distribution. I mean, you could actually gonna calculate it. And then idea is like if you just kind of throw the dice, right? So if you throw the dice and then you can kind of randomly choose one of the word, right? Oh, maybe I can get a like. Okay. Then what's the next word could be? What are the options? Okay, so one is okay. If you have the given like, so one is studying. Yeah, and a 2. So okay, given that, okay, I do have like a studying. So the given the previous word like and a studying, and then given the previous word like and a 2 is like 50% and 50%. Again, like this is a random, right? So we could just kind of throw the dice, and then okay, maybe we can randomly choose the studying, right? So in this way, if you do that, I like studying, and then the next word is again like add or computer science. So next word is gonna be computer, and so on and so forth. And if we do that again, okay, so the next word is a computer, is a science or the code. So okay, maybe we just gonna throw the dice and randomly chose code. And then the next word of the code is gonna be only apple. So automatically become an apple, and then apple next word is gonna be apple or banana, and then and automatically banana, right? So yeah.
Isn't it conditional on the previous?
Yes, that's a good point. So this is often called this kind of looking at just only the one word, and then which is called like an anagram. Maybe in the next slide is about. But this slide is specifically only looking at that one word. But then look at it. So given you have the model and a data sets, and then so trained based on this training sentences, and then now you actually generate, I like studying computer code apple and banana. So amazing. This is actually kind of, we can generate a new word out of the training data set, right? So that is kind of how the language model works, right? So this is amazing. And then you have, as I said, like it's called a diagram, but the sentence of this one is decomposed into the probability of this, the probability of this given this, probability of this given this, and if you multiply, then yeah, so 0.02 so that like a 2% equivalent. So this is the kind of toy, very, very, very small language model, but language model can actually train, and it actually works, right? So that is the kind of called diagram. So this kind of very simple probability distribution is often called like an anagram. So this language model is n-gram. So the n is given trying to predict the next word, kind of n equal to how many words you're gonna look at. So in this case, 2 gram, bigram is like n equal 2, meaning that to predict the next word, just only look at the previous word. Okay. And then the 3 gram is to predict the next word, you're gonna look at a two words before. So, but anyway, so like this, but in any case, like this is the kind of often called the bigram and a 2 gram, bigram and 3 gram. But it's basically gonna like a language model that look at direct previous sentences, previous words to predict the next word. And in the bigram language model, the probability of the next token, and just kind of look at the previous words, and then multiply it, and then you can gonna right. So that is the kind of toy example. Any questions?
When a model says that it has like a 1 million context window, does that mean that each individual instance it can have 1 million tokens?
So if you mean like n equal 1 million?
Yeah.
So n equal 1 million, then you when you predict the 1 million 1 plus 1 million token, then you have the exactly the same 1 million sentences before that. So it has to be exactly the same. So it's not really just kind of, in this case, the n-gram, by the way. And large language model is kind of training completely different way of doing it. So like a 1 million token is 1 million is fine, but 1 million n-gram is probably gonna almost doesn't work because, for example, even if you kind of 3 gram, then if you kind of try to predict studying, you have to have like I like studying, and then to get a computer, you have to kind of look at the two words before that. So 1 million n equal 1 million gram is gonna be to predict this word. You have to have an exact match of the 1 million, which probably doesn't happen usually. Yeah. So in the data set, so that is a kind of n equal 2. So in this case, so this is the kind of theoretical one, and then I also want you to kind of try it out by yourself. So this is kind of interactive learning material, by the way, which I bytecoded in a couple of minutes. So this is the kind of model, bigram model. So here's the training data sets. Okay. And then, so I like machine learning, I like natural language processing, I like generative AI, and so forth. And then you can first train, and then it's not trained over. And then, so again, like you could see, like here's the kind of next token prediction here. Right? So I is 40%, and then generate I don't know, some kind of probability. So given this like n equal 2 bigram, this is the bigram. Oh yeah, this is the bigram. And then you could just kind of pick the random one. Okay, let me start from the I. And then in this case, if you pick like I and then like, so the probability is 100% with like. And then next is the generative interactive machine, and I pick random words, machine learning, and over. So that is if you pick natural language models or processing, and models can predict the next word. Okay, so this is the kind of sentences. I like the natural language model predicts the next word. Again, like this is not like grammatically correct, but you can actually try to play with it. And I also do have some one of the data sets that you could kind of download it and use it. So if you paste it to the word, and you could now predict the new type of the words, right? So I want you to kind of try maybe I don't know, like a pair with the next person, and I kind of try to go to yeah, try to go to this website and then try to put some kind of different data sets and then try to kind of interactive learn like how this like a machine learning works. And then I want you to discuss or kind of try to think about what is the limitation of this kind of simple language model, and then when does it work and when it doesn't work, and what's a failure example and why. I just want you to think about it by using, I don't know, 10 minutes. So just kind of, just kind of try kind of different data set. You could kind of copy and paste it from some different, for example, your blog might work too. So just kind of put your blog and paste it onto the text or whatever to see how diagram, or you could also kind of choose, there's a diagram. Yeah, and then kind of trying to understand like how the background works. Yeah. And then after that, like a peer with the next person to try to kind of discuss. Try to discuss like what's the limitation. Yeah, what's the limitation, and like why it works, how it works, and when it works. When it doesn't work.
It would be, yes. It would probably
Can you? Yeah, so slide 26.
It's not outputting. There's a chance. Oh, yeah. But it's not very well.
And
But it's most likely based off the trains and that.
He is
So you said because that's my grade, you just like, yeah. And it's just big. Yeah.
definitely previous work, so we will not do the next work. Because we are just focusing on the previous latest work.
Okay. Good. Quite big. Like it's just choosing to some period was.
What's the questions? What were the questions?
Another period.
I mean, like, what's the
Yeah.
when it works and when it doesn't work. We're gonna try to discuss the gap. But imagine like you are time to the 1990s, and then you are the researching this one, and when it works and when it doesn't work, and then why do we have to invent new way of deep learning or even platforms? Yeah, kind of try to experiment this and kind of see.
So it is random.
Yeah.
If you increase the
Yeah, that should be
n value, then you would have more. Yeah. And the accuracy would improve, but the complexity would improve. We are going to complete that.
Then it could be. Which is gonna be.
Just going to search.
It doesn't make sense.
Look at more than just the one word.
Structure of the data set, they think, oh, here, we're just talking about yours. If you give it
All of
grade,
these sort of just statistical models.
Yeah.
technically.
Like sort of start to
Or I think
They
that
were about
large language models.
So.
Like attention. Which like allows us to go all of the.
Yeah, instead of just.
like unseen detail.
Larger.
Yeah.
Folder content. Build strings. So.
Or I think it's like, it doesn't have to be like.
You only go back, say, to this one. And then it's like, so.
Every
this-
word can be connected to each other, so you just get more context. I do not actually.
They find that some uses
So, yes, because you're eliminating.
Well, I think if we set it up with electric magnetic, I think it would still give us area.
I'm saying that.
Sure is.
I like
I,
machine learning.
then another word, the words have to appear together, so it's with the flow. And lifted said, the second word, it has many different options, but
Probability of next word.
all those is probability is one forward when you have.
The text data.
Yeah, so.
Yes.
There's
Because
It's
of
not
that, when asked.
Obviously versus.
like it can just trigger.
Yes.
Doesn't look at.
You're saying
Yeah,
if
like all the-
that do anything else, as long as you end that you work like exist.
This is by learning credit code and learning is probability of that is.
I wonder if.
I
No, it's not. That is a-
Well, so what I was gonna say is that if there was also something that like was like,
Depends. What's that thing?
I don't know.
Yeah, no, I know, so probability, yeah.
Right.
This is not a big sense. If we did this, it would still actually. Because
Like I like.
That is the size. Is.
Yes. Yes, I agree with.
I can't.
Explore options. A lot lower probability.
Limited execution.
Yeah, I think we're talking.
All right, I guess maybe we can finish. Okay, like first of all, I mean, like this is actually the model that was used in the 1990s. So, yeah, time flies. But okay, then maybe the starting from the what's a good aspect? What's a good aspect of this? Huh? Like what works or when works or what is a good aspect of this language model? Yep.
Seems pretty fast.
Mm.
Both to like train and generate.
Mm-hmm. Yeah. That's a good point. Another one. Yeah, it's just only kind of like looking at like a pattern merging, right? So it's pretty fast. Another one. Yep.
It would work when it would have seen all the data. For unseen data, it may not work because probabilities
Mm-hmm.
would be zero,
Mhm.
and then data sparsity of it.
Mhm.
So only if you have a domain and a
Right.
which you want to train, like
Yes.
for simple tasks, then it will work.
Mm-hmm.
If you are in a situation. It's fairly quick.
Yeah. That's also kind of how you can kind of divide the word too, right? Yeah, that is also we can cover. Yeah.
Should Excel producing semantically and grammatically correct sentences in English?
Yeah, it kind of generates. Yeah. One of the kind of observation maybe you could see is if you have actually kind of more data sets. I mean, like the first one is about like a six sentences. But if you have more data sets, then it actually kind of works kind of better and better. So that is kind of beauty of machine learning model. So machine learning model, if you have like a more data set, then it kind of even like the new words or very unfamiliar word, and you could somehow refer to kind of trying to find trying to find a word in the data set and kind of try to predict it. Okay, on the other hand, like what's the limitation? Why, what doesn't work for this kind of model? Yeah.
It's a statistical model, so it does not have semantic understanding. Language could have like nuances which this model cannot understand. It's just accounting.
That's a good aspect, and it's also kind of debatable aspect too, because ChatGPT is also a statistical model. So the language model, even like a large language model, is also still statistical model. And I also kind of bring the discussion to later. But is that like a statistical model mean that it cannot understand semantic or not? You know, that is also kind of one of the debates. So obviously, this is a kind of statistical model that doesn't understand grammar or even semantics, obviously. But with whether the statistical model itself can or cannot understand is kind of another question. Yeah.
Yeah, so well, you would think that if it's got a large enough set there, that our grammatical models are, you know, a noun usually is followed by an adjective or a verb. And so it doesn't have to know those concepts, but it would get them statistically anyway.
Yeah, kind of. Yeah. I mean, it's not perfect, obviously, but yeah. Yep.
I think building on what she said, it doesn't have semantic understanding of the words themselves. So as compared to other large language models, I think that's a big problem. Because that it just takes every word individually and it does not understand that certain words might mean the same thing.
Yeah.
Right, exactly.
They have some correlation with each other.
So for instance, one of the examples is that the word has many different meanings. For example, like eat apple, banana, and also a computer called Apple is exactly the same words, but it completely, you know, different meaning, right? So if you say like a queen, it's gonna be queen of the Elizabeth or the queen of the band. It's a kind of completely different. And so this model cannot really recognize the difference. That's the point. So they kind of divided based on the words. Anything else? So kind of related to that one of the big limitation of this one is the word, like apple, is the meaning of the word can be different, right? Like apple, banana, or the Apple company. But how are you gonna guess that word's meaning is kind of based on the context, right? But the context means that sometimes like, you kind of have how to say, you have to refer back to the more than n equals 2 or n equals 3, right? For example, if I kind of start saying like Steve Jobs and then maybe like a 10 words or the 20 words before, and if I start saying Apple, then it's gonna be more like a company, right? And so if you just kind of look at like a n equals 2 and n equals 3, then you cannot really get a context, right? So that is one problem. On the other hand, like if you just gonna increase the n, like n equals 10 or n equals 20, then it's gonna be becoming harder and harder to find the exact words, right? Or you're just gonna repeat the data sets words too. So that is a kind of any different type of limitation. But interesting aspect of observation is one is if you have like especially machine learning model, even like a very simple model, if you have more data sets, then you can kind of generate more richer, more expressive words, right? On the other hand, if you just kind of take a look at like just previous words, one is you don't really know the meaning of the word, and also related to that, you cannot understand, guess the context as well. And also the grammatically correct words, sometimes it's grammatically correct words, and sometimes not. And also more important question is whether the statistical model can actually understand or not, right? So that is a kind of, these are kind of a research question has been kind of raised a question back in the 1990s or 2000. And then, so what we just demonstrated is the n-gram, which is gonna happen around 1990. So even like 30 years ago, like even like a Google uses Anagram. So now it seems like it's too simple. Like it doesn't work at all. But even like 20, 30 years ago, it's actually gonna use it. But after that, like a deep learning model has been introduced. This is really like a 2010, after like a 2012. And deep learning model is more gonna, how to say, it's not just a simple anagram model, but it's more gonna kind of trying to how to say, kind of mimic the brain of the synapse, and kind of trying to, how to say, parameterize the kind of different types of models. So that is often called, so this one's a statistical language model that is kind of anagram. And then the more like a task agnostic feature, and back in around this era, like a model called like a deep learning model has been introduced. And then the real breakthrough was 2017, which is going to be covered next week. Google introduced like an architecture for transformer, and then a transformer actually revolutionized the entire like a language model works. And then the ChatGPT is also based on like a transformer model, and then the rest are you can see the history, right? Yeah.
When Google uses like rank brain for the search engine, would that be considered a machine learning?
So the Google has a kind of different so at this area especially, they have a different models for the different purposes. So anagram is kind of like trying to understand it, and they also have kind of different like a support vector machine model to kind of link between the, like a words and another word. So at this error, you're actually gonna have like a 50 to 100 models for many different purposes. So it's not like a generalizable. So it's more like a task specific. And then after deep learning, it becomes more and more one model that can do anything. But that is actually kind of after 2017. So even before 2017, for example, like for the question and answering, there's a question and answering model. For translation, there's translation, that kind of thing. So, so that is a kind of history. And then now we kind of understand the language model. So that language model is based on the language, and it produces the probability. And then now in 2026, we have large language model. And then the question is, what's the large? What's large, and how large, and why large? Maybe the first time, like what large? Like what is a large in this large language model compared to this? Yep.
It's just that it has a lot of data, that's it.
Yes, that's one. Yep.
It has a large training corpus, but it also has a lot of nodes in the internal structure.
Good point.
Layers.
Exactly. Yeah, parameter. So there are three large aspects. One is model size. So model size is the number of parameters. So the anagram doesn't really have a parameter. But what I'm gonna cover in the deep learning is a lot of lots of the parameters. So it's like a mimicking the human brain. So the human brain also has the I forgot the exact number, millions or maybe about a billion of the synapses in your head. And the synapse does just kind of very simple thing. But if you kind of train like how each of the synapses kind of move or like behave, and then as a whole, you can kind of try to mimic a kind of more complex thing. And then large here is kind of model size. So number of the parameters. And the second one is also actually on data sets. So as I demonstrated, even in the anagram, if you have more data sets, like a training data sets, and then you have large. And then the third one is compute. Compute is like anagram can only work with this kind of very tiny machine, but to train this kind of model requires a lot of computing power. So these are kind of three. And then how large is the GPT-3? So GPT-3 is the base, like a ChatGPT, original ChatGPT based on it. So it looks like just 5 years ago, had they didn't reduce it, but it's a 175 billion parameter. So meaning that like, it actually gonna calculate the 175 billion of the number of the parameters. And 300 billion token. So this is actually got a data set that we have. Yeah. So 300 billion tokens. So what we have in Harry Potter is probably about hundreds, right? Or maybe the 1,000. So the 300 billion tokens means that 300 billion words. So they collected 300 billion words from the internet. That's crazy. And then it's often called like a flops. The number of computes is they use the 1,000 of the NVIDIA GPU for weeks. So it's often roughly estimated like a 5 to 12 million US dollar, which is at that point it's so expensive. But when you look at it now, it's so cheap. It's crazy cheap. And yeah. Anyway. By the way, have you ever heard NVIDIA? So NVIDIA is the kind of company that sells the GPU. GPU is the kind of accelerated compute. So that is kind of faster to calculate. And then so this requires a kind of 3,000 GPUs. But I think now in 2026, maybe one company has 1 million of the GPU because it's kind of model become bigger and bigger. By the way, NVIDIA GPU is selling. So one GPU, you could also buy it, but one server side GPU costs about 100K. Yeah, maybe 50 to 100K, by the way. And then Meta or Google, maybe Google not, but like a XAI or OpenAI actually gonna order millions of the GPU. Yeah, so 100K times million is a kind of their revenue. And NVIDIA's profit actually got 80% of the GPU is a profit. So there, if you do the math, maybe that's why like NVIDIA stock is going up. But so why large is actually gonna have a better generalization. As I said, like, it doesn't have to be separate model, but one model can do almost everything. And then the second aspect, which is also interesting, if you actually gonna make it bigger and bigger, is somehow suddenly that can do something that was not possible. So that is often called like emergent ability. Yeah, think model many tasks and reduce need for manual feature engineering. So that is the kind of history of the long-term model. So as I said, like back in 2020, OpenAI released the GPT-3. So that is based on the first ChatGPT. So ChatGPT moment was here. Do you remember it? I mean, like I think I used the ChatGPT for the first time since a week or 2 weeks release after. So it's like a December 2020. December 2021? 2021. Yeah. So that was a ChatGPT moment. And then you have like a history of like many different people kind of releasing different ones. So this is kind of 2024. DeepMind and Google and Naver and Meta and so on. And if you look at this diagram, which is crazy. So 2017, Transformer was introduced, and then 2018, the OpenAI released the GPT-1, which is a kind of 100 million parameter, which is also kind of pretty good. I kind of started following from here. Like they released a GPT-2, which I'll also demonstrate next week. But GPT-2 was kind of shockingly good, generate good sentences, especially compared to the anagram. So we already knew the anagram, so how good their generation is. So this is more like a toy compared to the current model. And then that was also 1.5 billion, which is also amazingly, like shockingly big. But then people are kind of studying, kind of scaling up from, so this was the 175 billion of GPT-3. This was still like a little small, and then they not gonna release the model parameter anymore, but that was kind of GPT-4 was about a half to 2 trillion, and the GPT-5 is probably 5 to 20 trillion. That kind of sense. So it's kind of becoming bigger and bigger, bigger. And why? I mean, like, why people are kind of, betting to the scaling, right? The question, because if you're actually gonna make it bigger and bigger, you also have to kind of invest much more computing. For example, this was like a 5 million, maybe this was gonna 100,000, and this is probably gonna have like $1 billion issues, right? You cannot really do the gambling for $100 billion. So why people are just gonna keep increasing? So there is a kind of research paper behind it. So this is a kind of one of the most famous paper called Scaling Laws for Natural Language Model, released in the 2020, right before the GPT-3. So that is actually explain. I'm gonna try to do that kind of experiment, by the way. And what this paper explain is basically they fixed two out of 3 parameters, and I gotta check how each of the parameters change. For example, in this case, the data sets and then data sets and the parameters should be the same. And then if you kind of increase the compute, and so this is the kind of loss, which is often called like a performance, the lower level. So if you kind of have enough data sets and enough parameters, and if you increase the compute, and it actually gonna performance better and better and better. And even have the data sets, if you have enough compute and enough parameters, if you just gonna increase the data sets, and it's actually gonna better and better and better. And this is also parameter. Like if you have enough data set and a compute, if you just gonna increase the parameters, it's kind of becoming better and better. So, yeah.
I have a question on the first graph. So let's say if the data set and parameters, if the compute is enough for fitting those many parameters in the compute or memory, then why increasing the compute is reducing the test loss?
Oh, so here's kind of explanation about. So this like a blue line is about actually gonna given the parameter, by the way. So if you have a small number of the n, it actually gonna, if you have a compute, it actually gonna decrease, right? Obviously, but this is actually gonna stop around here, right? So meaning that like if you have like a small parameters, even like having a compute level compute, then it actually gonna stop around here. So this graph means that if you actually gonna given the number of the parameters, so they tested with many different parameters, and then it seems like each of the parameter line is like that. But if you actually can have the more and more parameters, and then the optimal point seems like a decrease. So that is the kind of meaning of how the compute is actually gonna enables the bigger parameters even now. And this is also kind of interesting because the model size n is large, and if you look at this line, even like a model size big, it's not enough, right? Because if the model size is big, and if you only have a compute like that, then actually if you look at it, the smaller model is even better, right? So meaning that this model size is not really trained enough. So meaning that if you have more compute, you can actually increase outperformance. So this is a kind of like what are scaling laws for natural language model. And then after releasing it, and people realize that, okay, that's easy. If you're actually gonna have more data sets and more compute, then we can actually outperform better. So that is the kind of, and it's still kind of happening still right now. And that is the kind of reason why people can't be 100% sure that getting number of the GPUs and the data sets to even like a $1 billion investment. by the way, so this is the kind of last author of this one, but Daniel Amadeo, does anyone know this guy? Oh no. Have you ever heard of a Claude or Anthropic? So Anthropic is one of the another kind of large language model. So they're kind of big four. So one is OpenAI, Google Gemini, and XAI Grok, and then the last one is Anthropic Claude. But Daniel Amadeo is the CEO of the Anthropic. So he is actually kind of left OpenAI after this, and then he made Anthropic out of this scale node. But another key person is also Alec Latford. So he actually made GPT-1, 2, 3, and DALL-E 2. And interesting point is that he's a college graduate, so maybe college dropout. So OpenAI is actually pretty much kind of like a PhD graduate. But Alec is one of the kind of hacker who is kind of genius enough to commit in OpenAI. So he is almost kind of he makes almost everything. And then another interesting observation is often called like an emergent ability of the large language model. So that is also 2022 again. Out from Google DeepMind and also Stanford. So emergent abilities is kind of interesting. So let me kind of try to explain. Yeah.
Sorry, I have a question about some of the other stuff.
Oh, yeah,
Can
sure.
Can you define what compute means? Like what are the units?
Compute. I think it's like a flop. So it's like a given the day. Flops is technically floating operation. Not exactly floating operation or something. So it's kind of given. So the GPU has the capability of the number of the computes per second. So it's often called a floating operation. Floating operation is matrix calculation. So it's kind of like a calculator, right? Similar to calculator. Like how many times that you can, how to say, types the calculator. For example, like A multiplied B is a 1 unit, for example, right? And then flop. So this is more like a teraflop. So I think a teraflop. So this means that more like a billion or maybe trillion times of the multiplying per second, right? So that is a kind of flops. And then they also calculated the total number of the flops. So if you have enough flops per second, then if you kind of run like a 60 seconds, for example, you could just kind of multiply like 60, right? So that is the kind of number of the total flops. And then, so for example, if you have like a 1 week or the 6 week, you could just kind of multiply the days or the times of the based on like a number of flops. So that is the kind of basic understanding of the compute. So compute is basically kind of how many times you multiply the number. Yeah. So that's a kind of the unit of the compute. So it's not only about the number of GPU or number of CPU, because different GPU have a different calculation capability. So they actually gonna based on the unit. So yeah, going back to the emergent abilities. So let me explain this one. So they actually kind of tested the different number of the parameters. And then, so this is the kind of number of the parameters or the number, like a size of the model. Okay. And then these are kind of different tasks. So let's look at like arithmetic. So arithmetic is kind of very simple, like arithmetic exam, right? For example, such as 3-digit addition or like a logical reasoning or the coding. So these are kind of arithmetic. And then, so this is translation, Q&A, and so on so forth. And if you look at it, so these are kind of, for example, like GPT-3 or the Lambda. And then if you have like a lower model, then it, for example, up until like 10, 20, yeah, but up until this size, there's almost no increase, right? And then like people almost gonna give up, and then suddenly, if you just gonna increase from here to here, it suddenly, ability increase, right? So this is kind of emergent ability. Like it's not like a linear, but if you just for example, usually you think if you just keep adding the parameter and it linearly goes, right? But idea is GPT-3 and the GPT-4 is not like a linear. If you just jumps up at some point. So this is the often called emergent ability. And they show that if once the model size purpose until like a threshold, it suddenly dramatically increase increase the performance or increase the capability. Yeah, so that is a quite interesting aspect, interesting observation of the emergent ability. And why? But so it's kind of interesting because that is not happen only once, but it actually gonna happen before in a different domain. That is the physics. And in the physics, historically, back in 1960 or 1970, physicists almost think, oh, okay, like physics was solved because the quantum mechanics is completely understood, right? And then if we just the world is made by quantum or made of atom. So if you know the atoms and if you can calculate everything, then you could actually understand everything, right? And then back in 1972, I guess, like a famous paper called Philip Anderson from Nobel physicist say that no, it's more is different. So this is the paper title, by the way. More is different, meaning that if you have more, it has a different. So it's like there is phase shift between small. It's not like a sum of the small parts, but it actually phase shift. For example, like if you have a water turning into steam, at some point, water is just water, right? But if you just increase the 1 degree from 99 to 100, then the behavior is completely changed, right? So this is also called a phase shift. And then even in a frozen water is also the same. So at this certain threshold, it completely behaves completely differently. Is often called a phase shift, and that is this is also very unique and interesting paper about it happened in physics. And then after this one, and then the physicist starts looking at why it happened, what is the governing laws of this one. And then the same thing is happening in AI and neuroscience too. So why emergent ability happen? Actually, we don't know yet. So even at the state of the research, it's just a hypothesis. So we don't really know why it happened. There are some hypotheses, by the way. So again, these are just a guess, by the way. And the first step is about a multi-step hypothesis. So, for example, if you have a complex reasoning, then you're actually gonna have a multi-step reasoning, right? So, for example, if you have to calculate it, then you have to do a summation, and you have to do the multiplication, and you have to do the multiplication again, and then it's a chain. So if one of the chain, for example, if one of the chain is so if you reasoning, you need to solve these 4 steps, and then this is okay, but this is not, then it's gonna be the rest is force, right? So even if you have 0.5%, 50% chance to 50% chance to succeed here, if you multiply it, then the actual answer here is gonna be very small, right? But if you're actually gonna increase 0.6 or 0.9, then everything is gonna 0.9, 0.9. So this is gonna like a fourth step, and if you multiply it, this difference is too big, right? So this is kind of multi-step hypothesis. And a second hypothesis is kind of called grokking. So grokking is the kind of first model is kind of try to memorize everything. But if you have an enough capacity, then you could actually kind of, how to say, kind of start trying to understand underlying algorithm or underlying like a principle without memorizing everything. And then this kind of switch from the memorization to understanding and actually kind of code the jump. And some people can say that, oh, this is just because of the more like an aspect of the evaluation. And if you actually kind of closer look at like each of the model, it looks like a more like a linear the increase. So it's also somehow part of it too. But we don't actually know yet. So I think what AI or neuroscientist people is actually kind of trying to discover the underlying principle of the emergent abilities, similar to how physics evolved back in over the last 20 to 30 years. That is a kind of, so that's why AI research cannot be just only made by AI, because neuroscientists also knows a lot of, have a lot of knowledge about human brain. So it's kind of like going back and forth between. By the way, grokking, are you familiar with this name? Have you heard somewhere? Yeah. Yeah. Oh yeah, exactly. Grok from XAI. Oh, good Grok. I mean, do you know Grok?
It's still a word.
Yeah, I mean, like X, previously Twitter has a Grok, and Elon Musk is making the XAI, and XAI is making the Grok. But Grok is actually coming from this Grok. So Grok is suddenly kind of trying to understand the word. And then going back to the question, that even all with that, like a large language model is still just a statistical model, right? And so LLM just kind of predicting the next word or next tokens, and based on the probability distribution. And we did a kind of toy problem, like an anagram, that even large language model, like even large, is still just a probability distribution, which is a kind of language model, right? And then do the LLM can really understand the content? So, what I think. Or they can even kind of reason, or they can even like comprehend it.
What do you mean by understand? Like they understand the embedding behind it.
Well, it's I kind of try to avoid that definition of understand, but I understand here that it's definition of understand can be kind of can be different based on kind of machine learning on AI people or more like a linguistic people. But it's more like just a natural meaning. Yeah,
they definitely understand the content, like through the embeddings and the link between the embeddings and how this works. So, how would you define intelligence? Like, is there a threshold?
Yeah.
Then because they've already passed most of the Turing tests. So
yeah, it's also kind of good point about it. Yeah, what's the intelligence? Like, and yeah, it's also kind of important aspect too. And also like so it's kind of interesting debate about if this is just kind of pattern matching, right? Or it actually gonna really understand the context or not. And there's a kind of interesting discussion with the Edier and Johnson. Can you hear me? Oh, by the way, do you know him? Who is that? Who is this guy?
Jensen.
Yeah, Jensen Huang, the NVIDIA CEO. Who is this guy? Oh, no, not really. So he's an area subscriber who I think in my opinion, that most of the opinion, he's the smartest, most intelligent guy in the world. He developed AlexNet. So he's a PhD. He was a PhD student from Jeffrey Hinton, who is the godfather of the AI, and he was the founding member of the OpenAI. So he actually built ChatGPT, by the way. And then he kind of tried to fire Sam Altman, and it didn't work. So he left, and he's now working on a safe superintelligent Inc. to make the safety superintelligent. But he made a ChatGPT, and then kind of explains about. So let me just
now perhaps accepted by many at this point.
Try to
fix the next word with greater accuracy. This is really important because the better a neural network can predict the next word in text, the more it understands it. This claim is now perhaps accepted by many at this point, but it might still not be intuitive or not completely intuitive as to why that is. So I'd like to take a small detour and to give an analogy that will hopefully clarify why more accurate prediction of the next word leads to more understanding, real understanding. Let's consider an example. Say you read a detective novel. It's like a complicated plot, a storyline, different characters, lots of events, mysteries like clues, it's unclear. Then, let's say that at the last page of the book, the detective has gathered all the clues, gathered all the people, and saying, okay, I'm going to reveal the identity of whoever committed the crime. And that person's name is.
Predict that word.
Predict that word. Exactly.
My goodness.
Right?
Yeah, right.
Now, there are many different words, but by predicting those words better and better and better, the understanding of the text keeps on increasing. GPT-4 predicts the next word better.
Ilya, people say that.
Yeah, so this is the kind of quite interesting example, isn't it? So if you read a detective novel, and then your last word is the person's name is, and if it can actually predict it, then does that mean actually it's just that predicts the words, or it actually reason, understand, and comprehend the word? Yeah.
But that's a no-way deduction. It's just essentially you give it a context, not giving it any reasoning ability.
Well, but for example, it kind of depends on, right? Because, for example, like a human reads the detective novel, and you also know the context, but can you still?
Yeah, but like if a human read the book, for example, and there's a difference between someone who reads the book and they figure out who the killer is versus if they read the end and they cheat, you'd say they cheated, right? Like you didn't say they figured it out, you'd say they just, if it was just told to them. So that's kind of like, I think, it kind of breaks down the
Yeah. Yeah.
I think that we're moving into a world where we measure things like large language models differently than we have before. So you put a bunch of charts up that had numbers on them that are traditional flops and things like that. And then if you look at what Meter's using now, I think you might be familiar with, it's a nonprofit that is now using a different way of thinking about measuring the capability of artificial intelligence, comparing it against complex tasks that a human would do and how long it would take you to do them versus give the same task to the AI and its percentage of success and how long it takes to do it. And it plots them over the generations of the models and shows that the level of complexity of the task that it can complete is going up fast. And then measured against human beings, the time to solve the task is collapsing. So I'm not sure it matters how we define intelligence. I think we look at these things as what kinds of things can they do and how fast can they do them.
Oh wait, is that a question or
no? I was saying that. I think we might sometimes be using the wrong metrics to understand what's happening.
Yeah. I mean, there are also actually going to debate about like a definition of intelligence, obviously. But I mean, like, well, it's also kind of good aspect, good point about like whether it's just only understand the context or it's actually reason. So that's why like the AI researcher have to look at the inside of the each parameter, kind of trying to kind of understand like what's happening in the process of the GPT, which is GPT or other model, which is actually going to happen in real time. In right now, people are kind of looking at each of the parameters to kind of try to understand like what's happening inside of the brain or inside of the brain of the LLM. But still, I mean, either it's kind of reasoning or not, but I feel that this just only the predicting the next word, even with a statistical model, can be considered it's not like just a predicting word, so it's not really just a pattern matching, right? There should be some kind of understanding, even not a reasoning, it's some kind of understanding, comprehension, the context, or even the word. So that is kind of how ADR is kind of saying it, and LLM is essentially what he's saying is the compression. So the compression of the knowledge of the word, because the 300 billion token is basically gonna almost all the text tokens in a word. And then so that is kind of compress all of the knowledge into the tiny parameter. So LLM is kind of just memorizing word is also not really true because the parameter or the size of the model is much, much, much smaller than the size of the data set. So you cannot really, if you have to memorize, you have to require like a couple of petabytes, model, right? But currently the like LLM is just only like a couple of gigabytes, right? So you cannot really memorize everything. So essentially, it's just gonna compress it into the data sets, and then the better neural network can predict the better in I kind of understand it. And also, if you kind of look at the human brain or how human does is also when we kind of say maybe we are somehow thinking to predict the word or kind of generate the word instead. Oh no, I'm not sure. So that is kind of why it's kind of quite interesting, like how AI works and how human brain works. Also kind of quite interesting similarity too. So there are so many interesting, interesting mystery out there, and why researchers kind of doing it too. So that is a kind of, one possible answer, even though it's kind of like predicting the word, but it's still kind of trying to we could somehow see, Anagram is obviously not really reasoning, but for the deep learning model is somehow, understand it, like a reasoning too. So that's pretty much it. So as I mentioned, like Anagram is what we covered today, the 1990s, and even better and better. And then that evolution has happened because of the transformer. And then the next week, I want to cover like how the GPT is actually built, and then what the transformer architecture is. And then what is some of the embeddings, like a pre-training works in a kind of different domains. And then for the week after that, we're gonna focus more on what is application of the by using RAG, tool use and things on. Any questions so far? Yep.
Just to clarify for enrollment for those that are on the wait list, how is that going?
Yeah. So sorry, I mentioned that. So I asked to increase the size by changing the classroom. They said there is no classroom anymore. So another option, they asked me whether I'm open to the remote session. So I gonna probably ask them to open the remote session so you could take it. Although it seems like you could still attend in a class. So I can also probably do the Zoom, but you could also still attend. I haven't done a remote session before, but I guess it's probably the same regarding it. So so you could just enroll it. I'm also gonna, maybe some student here or not here might drop you out. But anyway, I kind of try to create a demo session, so please kind of take it instead. Yeah.
If they automatically unenroll us on Friday, because that's the deadline for dropper adding.
I gonna try to try to work on today, but to be honest, I don't know the logistics, so I gonna try to make sure. I'm not sure how it how it works, but kind of try to work on it. Yeah. You had a question? Okay.
Would we get to know if the remote session is open?
So okay, I'll figure out today. Again, this is kind of out of my capability, and I can probably send you an email. Yeah. Okay. All right.
No, don't think about
So last semester, maybe that's the John said. So last semester, I was in his special topics AI class, and it's also super exciting. I was just curious, by when we need to have like an idea for some project.
Yeah, we got pretty. How to say? We gotta probably have some kind of all of things at some point, but it's not a gradient where you can also kind of do. I just want to make sure each of the students. Yep. Oh, me? With me? Oh, okay. I mean, like, well, yeah. So I can accept the independent study, but also kind of mostly work with one of the so they already have a project. So I recommend you to do my okay. You can just kind of knock the door and kind of talk with the people. There are also what's it? Can you actually? Oh yeah, you could also kind of come today. Or can you kind of send me the email about the independent study, and we do have like a PDF for each of the projects, so you could somehow see like a week might be along. It may not be late, like if you can actually see the project.
For this semester?
Not really. Yeah, but most likely you're gonna also work. You're gonna work with one of these people. So I recommend you to kind of talk to each of them.
That's what I did.
And then one of these yeah. But yeah, talk to them and then kind of try to match, and then let me know.
Oh, I have a quick question about the cross topic. So how deep, for example, for that, that's what I'm most interested in.
Okay.
Like how depth are we going to get into those topics? Like are they more like a Wikipedia level, or it's more like I mean, it's sorry.
So again, we have to cover a lot. So maybe each it's kind of like a similar depth of today as today.
Okay.
So it's not super depth, but
Are you able to maybe upload like the PowerPoint for week 3 before the abstract day? So
I think so. And okay. When they have the
I have no clue. Some was like this Friday, but I think
maybe let's see. Yeah, for the week, or yeah, maybe I could do it. Yeah,
I mean week 3 is good enough. Like this one.
Okay. Yeah.
All right.
But it's more like like a
intro that.
It's not really like it's not about like a log class.
I see.
It's more gonna try to scratch the surface.
Yeah, sounds good. Perfect. Thank you.
Okay.
Hello. So I'm thinking which courses to take this semester, which ones to drop. I've already taken the NLP course last semester, so I wanted to ask if this course is going to be focused on LLMs and ML in NLP applications mostly, or is it a good course to take still if I've just finished the NLP class?
What did the NLP cover?
It covered transformers, A lot of stuff, yeah.
Okay.
Decoder only, encoder only models. We did the same about shared task for the final project. It covered embeddings, all the stuff basically.
I see.
By Jim Martin. The class was given by Jim Martin and uses his book.
That is covered next week. I mean, week 3.
React was covered to reasoning, train of thought, through, yeah.
Yeah, so these are pretty much for LLM kind of part, these 3. And then like a week 6 is more than vision, yeah. But kind of similar level. I mean, like we are not really doing a lot of math or the coding during the class. So I mean, kind of how to say it's more kind of similar to today.
Yeah, it's a 7,000 level class, so it's more discussion, reading research and stuff like that. I also wanted to ask specifically about sound generation models, music, sound, like Suno. I was gonna touch that. Because I'm
maybe some of the maybe I could probably school.
Not sure yet,
some of the advanced topics. But again, it's the here more kind of trying to
years and
understand the overview rather than one specific.
Oh, okay.
One specific one.
So it's basically modern AI
graph pairs and
business, or whatever is going on with.
Yeah.
But okay, I got it. Thank you so much.
Yeah, I don't know what like an NLP covers, so maybe you could decide.
It covers everything up to week 6 basically. Yeah, I'm gonna think about it. But thank you so much.
Yeah.
Cool. Have a good day.
Yeah.
You're not with Lockheed, are you?
For our, like,
but I do
we were
work
to go to
the project isn't Boeing right now.
for our project, what classifies as an AI application?
And I do
Like,
work
if
with
you have Super Bowl,
but I'm trying to
say
get
you're making some
access
sort of text messaging
a funded
service,
project to work
and
on,
you're having
this
AI generate a certain response to the user.
eating.
That
Let's say Stevie
would that be considered
Yeah.
an application that works, or is that just more of like a wrapper?
I mean, even like a lot. I mean,
Just finished.
You know what I
actually,
mean?
most of the AI startup
Writing
is
the
still.
request for information.
It's like not all
yeah,
that
it's fine. It's fine.
Okay.
Yeah. I don't really expect you to kind of try to do.
That's definitely a bigger deal than my question.
Pretty hard.
Yeah.
And I mean, like, even like a startup.
I was
you know,
gonna ask
like
about
90%
like
of
the
the startup
split.
is just kind of using.
People think
But it
that
doesn't mean
like predicting leads to
With like maybe
intelligence
some
versus,
super
like,
nuanced information
Well,
about.
I mean,
like,
like,
a little louder.
you just kind of.
I'm curious if
even
it
like,
seems like there's kind of a split
you just
in
kind
the
of
research world
make-
of predicting
maybe
leads to
that's
better
kind of
understanding than their
value.
or if
Yeah.
If you have any kind of target user and you have.
to happen
So
before
I don't.
models can actually
For the startup, I don't
solves
really kind of.
not necessarily
measure
keep
that.
info.
Novelty per se.
So,
So that's why it's more like.
One thing that I think will really interest you is
Evidence.
of
you know,
all of the
how
large
people are thinking
teams,
of it.
because
Okay, I have an idea, and I wanna ask you.
understanding what's
So,
going on in the model.
businesses get reviews on Google and Yelp and
Change the
whatever,
model
right?
So that it's all
But
different.
it's kind of annoying to sign into the portal all the time and write out those reviews. So I wanna bring it to text, where instead of you having to log into the portal and answer your review, the review will get sent to your phone via like Twilio or some other service. And then you can have AI help you generate a response based on your image and all of the data.
So if you go,
input,
they're extraordinarily open about it.
and then you can, click reply from there and via like a Google API.
Interviewing
It'll
themselves,
upload.
the team,
Like with that-
they've split into several teams,
with
one
that-
of them is.
Yeah, I mean, like, that works, but I recommend you to, first of all, like, a kind of take a look at, like, what is this
When they
style.
wanted to figure out how it
That is
fits,
like
so they
nothing.
told it, tell us how you think when we give you a problem.
So once you have, this is
So
kind
now
of,
all the
once
models
you
do
have
this, to the extent Anthropics is the best,
what,
but it creates a
what-
scratch pad where.
Yeah.
Solve
I've
the
done some
problem
research
here,
that's
and
seen
it says,
Yeah,
here's
and
what
it
I'm
seems
doing,
like,
solve the problem
they-
while it's doing it.
There's companies that do something similar, but it's not via text. Because
Really?
there's
Yeah.
automatic
This is
replies,
fascinating.
and staying up to date.
No, that's actually super
It's
interesting.
like,
'cause I-
And what
the review system, it's almost like you want AI to help you generate it, but you don't want it to completely do everything.
Okay.
Because it doesn't
So-
on it.
Okay, great. Then
You know
the
what I
next,
mean?
yeah, then great. The next step is gonna be also you're gonna talk to the people.
They don't
Okay.
really know how.
Maybe there should be like a top,
The way
you know,
the
I'm
models
just like,
work.
I'm not sure. I'm
Models
not
have to
sure
really
there's got a specific.
theoretically
type of
understand what
That-
they're doing.
Yeah, these are like hair salons, restaurants.
Right.
Yeah.
Like small businesses
Yes.
where personal connection.
Exactly.
Work
So
is
then,
really
yeah,
valuable.
you're gonna
And so
talk
the
to them.
account guys were like.
And then whether it's actually the problem or not.
And
The interesting
that's
aspect is that you actually talk with them.
when it
You
departs
gotta discover
from
new-
the preset
new
goals.
ideas.
Yeah.
Sometimes you
Yeah.
gotta, you.
Well, it just didn't
develop.
It
And
it
sometimes
skipped over
they-
that,
they people
right?
understand.
Weird.
Oh, it's not
And
even.
so,
So,
they've written
recommend
whole
you
papers
to
on
talk
it
to
and.
the people.
Go to some
kind of-
business.
kind of
Yeah.
explain exactly, and then
But-
kind of try to
Anonymous, but,
solve the problem for them. For
Okay.
example,
Really
Airbnb
interesting shit.
is-
But it
Yeah.
starts to get
in the
into
Y
the whole
Combinator
thing that you're
style.
talking
Say
about.
that one more time.
Airbnb.
Where is this thing going?
Airbnb.
Yeah.
Okay.
Well, that's
Airbnb.
super interesting.
Okay.
That ties in. I'm doing some contract like training work where I follow like model reasoning.
Oh, yeah. I was just
I
like,
didn't even think
So
that.
Airbnb, they created services,
Yeah.
but first they did it is
Well, I've been
they
really
went to
interested
the
in this
New
as we
York,
go on because I.
because in New York,
Probably
most of the
last
people are
25 years
100
on
or
the
maybe
DoD side
thousands of
designing
people
next
are using
generation.
Airbnb.
intelligent
And then they
control
started
systems for
going to
warfare,
that,
Right.
they started going to the New
And
York
we've gone
and kind of
from,
find the interview.
having,
why they use it. It's a very
mandates
big
that we only had.
because they were not
controls
using
from
that
the
many
users.
Yeah.
at that point.
Yeah.
So they were like,
Who's
why
using
do you like
Yeah,
it?
why,
Fairly
and then it
deterministic.
turns out Airbnb
Now,
used to be
about-
air, bed and breakfast.
About the time.
So you're gonna host stays and then also
there
the,
was some
they
work going on
provide
at
the breakfast.
Berkeley.
And then once
professor
they
named
talk to the
Clark
customer
on,
and host,
on
they-
emergent behaviors and emergent behaviors.
that they
are
don't
when
really wanna.
The machine does something that you didn't
So
predict.
we don't really need
And then try to
the,
figure out why.
Yeah.
we just need a place.
And.
And
you know,
then they
get a
drop
lot
the
more
breakfast.
emergent behaviors.
It was like PayPal.
Yeah.
Elon Musk and PayPal,
Yeah,
it
exactly.
used to be
Yeah.
this big thing where it was an email service, and then there was like this small little feature at the bottom
Yeah.
that was pay via email.
Yeah, exactly.
And then they were like, we don't want any
Yeah,
of this, we
exactly.
just want this feature, and then it, became PayPal.
Right.
So, yeah, sometimes if you
But
talk
those
to that,
systems in
people,
complex
and
work.
you can actually
like
get
war,
interesting insight.
um,
And the interesting
those
part, like,
systems are
many
much,
people
much
try
better.
to build the
They
same thing.
win if you
Not many
fight
people
deterministic
know the
systems
exact
against
insight
these
that you have.
goal
Because you
seeking
see
and
talk.
risk avoidance systems.
Yeah.
Or
risk
even
avoidance
kind of-
goal seeking systems always win.
If you are kind of
So-
running a restaurant, you.
That was about the
Problem.
time they were starting to
So,
switch.
yeah,
into
I mean, like, that's
maybe
great. So
we
maybe
could
I'm
have some of these systems
maybe this is
you
something
produce.
and also kind of follow the
Because
user.
Chinese
and
are
try to
switching
design based on it.
deterministic.
And even like a very simple
Non-deterministic.
one, like if it
And
works.
that means that they'll beat us on the
What I want.
battlefield, so
Okay.
Maybe they
we don't
use like a
get super.
secret.
Yeah.
Yeah.
I
Having
think it
control
could.
of every single
I mean,
thing that machines.
Those are the sorts
Right.
of services that I see that make money.
Yeah,
Like
yeah.
like micro software, where it solves one problem.
And now.
People don't want to log in, but they really want to be connected.
So
to their
everything
customer.
is being
That's the kind of what I'm looking for. So that it's not like a
And
that's
now,
only like
I've been
whether
involved
it's
heavily in.
but if you actually kind of talk
AI
to people,
systems
they
to,
they
all
they
kinds
will
of different tasks.
and we kind of develop the
Mostly
like
aviation.
didn't like it or we
That's
discovered
my
a
expertise.
new problem.
Okay.
Like
And that happens to be the fastest.
Okay. How would you recommend getting in the door? You think I should just
Right.
go?
Biggest difference.
You think I should just go inside and say like, where's the owner?
Yeah, this is the kind of you have to.
And so now, it's really interesting how.
I just want to run like Google Ads and
Yeah.
have it all, but you have to get talking.
Yeah. You can start with brands.
Yeah.
Really the
Right.
challenge.
Yeah, they're using models to try to
That's actually
understand.
kind of
So we're taking
You like
like
that?
agency.
Yeah, and so again, like,
Teach them
it-
not to fly
it's not like a big
Gotta do that.
deadline. You have to
But how to fly an airplane with 20 other.
Do you have any other
airplanes,
ideas?
you just have
I'm not
figures in them.
theory. I mean, I did have a research idea along.
What's a training system look like?
But I didn't
That's-
want to
that's-
hear
That's the
crazy idea from.
specific focus.
No, that's good.
Yeah.
How do I make a simulator?
Alright, well, I'm gonna think of the more.
Thank you.
Yeah, keep me updated.
Take care. Anyway.